X'talVisor, a full open-type head-mounted projector. At SIGGRAPH 1999, we presented the head-mounted projector as a wearable display for augmented reality. This year, we are pleased to introduce X'talVisor. Face-to-face conversation is a very natural form of communication. In addition to the exchange of words, natural conversation contains various kinds of information such as gestures, facial expressions, and so on. However, when communicating with persons in distant locations, it is not easy to actually unite people as if they were face-to-face. With wearable displays like a see-through HMD, the communication partner may be displayed through stereoscopic images to give the feeling that they were close at hand. But we must consider the impending real field of view as well as the impedance of the face by the HMD when capturing video. For situations like this, it is not only awkward, but miscommunication can easily occur without the ability of reading each other's facial expressions. Moreover, since the wearer's field of view is severely hampered by the HMD, it is too uncomfortable for many practical applications. Our new proposed display, X'talVisor, is a fully open type. To handle images from most fields of view, we use a micromirror for projecting the reflected light in front of the wearer. X'talVisor uses retroreflective projection technology to present images such as the following. This appears to be an actual model of Sony's Aibo rotating inside a gray box. However, this is in fact a virtual image realistically projected onto three-dimensional screens. The man standing there seems invisible. He's not a ghost, he's wearing a special overcoat with optical camouflage. These are two examples of RPT, retroreflective projection technology. Retroreflective material is composed of millions of tiny glass beads that reflect rays of light in the same direction as the source. Not only is this property useful for safety equipment and road signs, it leads to many new possibilities for visual display. Using retroreflective material as a screen, we assembled an optical system like this. This projector, placed at a right angle to the line of sight, projects a back image. This image is reflected by a beam splitter to the retroreflective screen and comes back in the same direction, so the image can be seen on the screen without distortion even if the screen has an odd shape. For X'talVisor, we improved upon this optical system and the half mirror which covers the field of view was abolished. Instead of a point light source, we pass parallel light through a liquid crystal panel and converge it onto a micromirror and project it onto a screen. The light reflected from the retroreflective screen returns to the mirror and enters the eyes of the nearby wearer. In this form, the HMD may be worn comfortably and the visibility of the wearer's face is left unimpeded. At Emerging Technologies 2005, we'll demonstrate how X'talVisor allows communication with a high sense of presence. Two participants wearing X'talVisor observe each other through stereoscopic color images projected onto a free-form surface covered with retroreflective material. Since X'talVisor does not limit the real field of view, it can be worn with the same feeling as ordinary eyeglasses, which is crucial for natural use in collaborative environments.